Today I'm going to show you how to delete the particles in SimuLauncher nodes when they hit an object. So let's see. Okay, let's start creating a simple particle emitter in geometry nodes. We are going to use, like always, SimuLauncher zone, our best friends. Let's connect this here and let's make some space. Now we want to add some points, so let's use points and let's use join geometry, because we want to add points in the middle of this process. So now we have a lot of points if we press play, but they are not moving because we don't have any set position and any vector. So let's create the initial velocity. Let's create a vector using a store name attribute. Let's add it here before join geometry, and let's select vector. And I want that the particles go in all directions. So I'm using random value. Let's call this velocity. And I want that for every frame they have a different seed. So every new particle have a new vector. So let's use a scene time frame. And also what I want is to add here vector math and select a scale. So if we add it here in the middle, we can scale this vector. That means the velocity. We can reduce or increase it. So let's select this and call it initial velocity. So we know that this is the vector to move these points. Now let's use this vector to move these particles, because right now if we press play, nothing happens because there is not any set position. So let's add set position and let's use this vector that we created with name attribute. And you can copy this and paste it here to go faster and connect it in offset. So now if we press play, we have a particle emitter. Perfect. If you want to decrease the velocity, decrease the scale, as you can see. Okay, right now what I want is to send these particles to one direction. So later I'm going to add an object and we're going to try to delete these particles when they hit the object. So as you can see right now, I'm going to add more particles by frame so you can see better the direction. As you can see, the particles go more or less in this direction. This one, and up. So from 0, 0, 0 to 1, 1, 1. That's why, because we have here 0, 0, 0, 1, 1, 1. So, for example, what I want is to send all the particles in this direction, more or less, something like this. So, to do it fast, let's go here, and I want to open the y in negative, so let's select something like 0.2. I want to reduce the y here, so, by the way, this should be negative. And here, I'm going to select 0.2. Let's restart again, and now you will see a difference. Okay, now let's reduce these ones that go up. That's because we have one here, so let's select 0.2. And let's select here, I'm going to copy this and paste it here. So now we have something like, when I'm going to press play, something like this in Z. Let's check it. Perfect. And we have some particles not going there, as you can see these ones, because we have 0 in X. So they start here and they go up. So let's push these ones because they have 0. So let's increase a little bit. Let's try to see how they react. A little more. Let's select, for example, 0.8. So all the particles go there, some go faster and others slower, because some of them go to 1 of velocity in X and others start with 0.8. Okay, so you know how to project particles to a direction with a constant velocity. Now, let's add an object here and let's try to delete these particles by hit. I'm going to use our lovely monkey. I'm going to move it in X, add it here, for example, make it bigger, and really important, let's apply the scale with Ctrl A. Apply a scale, and let's rotate it in Z 270 degrees. Okay, let's come back here. I'm going to lock this. And right now what I want is to use the information of this object, because now the particles are going through the object. So, first of all, let's open this and bring object info and select Susan. Now, how we delete the particles when they hit this object? By the way, I don't need so many particles. I'm going to select one again and start. Okay, so first of all, what we need is delete geometry. So let's move this and let's use delete geometry because we want to delete all the points, right? If now we leave this here and we don't make any selection, it's deleting everything. So I'm going to show you two ways to delete the particles when they hit this object, so you have more knowledge. So the first one, by the way, really important, select here relative. So the particles know that the object is here and not in the original position. So let's select relative. So the first one is using geometry. Let's select proximity. This one. This node basically is taking the distance between the object that you're using and the geometry node. So in this scenario, I'm going to make this the particles. This node is calculating, for example, the distance or the position, and we are going to use the distance between every particle and the main object. It's calculating the distance, right? So what we can do is to create a rule here and say, hey, only delete the particles that the distance between the particle and the object is really short. So how we do that? Let's activate this. I'm going to move it here. And let's use less than. Let's select float because we are working with float. And let's connect distance here. And now we can define a minimum distance before the particles are being deleted. If you leave it in 0, it's not going to work. Look. So you have to write something like 0.1 or less, or a bit more. I'm going to select 0.1 and restart the game. And let's see what happens. So as you can see, most of the particles are being deleted. Some of them looks like they go through the object, but actually they are not hitting the object, as you can see. They are going there. But if I put the object really close, you can see that we are deleting almost all the particles. Let me see. Yes, now it's working. So this is the fair option. If you want, you can decrease this, but sometimes if you make it too low, some particles maybe are going through the object. So try to play with the values. This is the fair option, as you can see. And the second option, I'm going to let this and this, is using Raycast. So let's bring Raycast. And if you don't know how this node works, I recommend you to watch my tutorial where I explain you really well how it works. But I'm going to tell you the important thing for today. So this node basically, as the name says, it casts rays. So this node needs a target, an objective to say, hey, where the rays are going. So our target objective will be this. So that's why here we are going to connect geometry to target geometry. And now we have a lot of things here. The only thing we want, we could use this hit distance like before. So to explain you how this works, let me mute this. Once you connect this in the middle of this process, what is happening, if we connect this, is that every point will be the caster. That means that every point is going to cast a ray. Okay, imagine that every point is casting a ray. So what we can do, we are analyzing the information of the target. So of this object, Susan. And we can check, for example, if it's hit. That means that if the ray is hitting the object. Also, we can get the position when it's hit. We can get the normal. We can get the distance. This is like before in proximity. We can say in which distance you are being hit. So we can define a rule and say when the distance is really short, delete the particle. But we are not going to do this. First of all, now the rays are not going in this direction. How I know that? Because the direction is this, and it says -1. So now all the points have this direction. As you can see, -1, right? And also they have a ray length of 100 meters. That means that the ray that is being cast is really long. Okay, so what we are going to do is to use isHit. So to check if this ray is hitting the object. If we connect it here, I'm going to unmute this and connect it in the Boolean. We are saying only delete the particles that are hitting the object. And if we press play, it's going to work. As you can see, look, it's working. Even so, we have the rays wrong. Why? Because when it's inside or really close, the ray is hitting the object. But we are going to do it well. So to do it well, first of all, we need to fix this. So what we should do is to select, for example, if this is positive X, select 1. So now all the particles, the rays, are going in the right direction. And if I press play, as you can see, nothing happens because the ray length is too long. So that means that all the particles have a ray length of 100 meters and it's checking that it's hitting here, so it's been delayed here. So let's select something like 0.1 and now you can see the particles appear again. Okay, however, in real life or when we play with simulation nodes, the particles sometimes don't go straight forward, right? Maybe we create with a noise texture a movement that they go like that. So we cannot define a direction like this. So how we say to the particles for the future tutorials, please can you check the direction in real time? So these vectors to project the ray for every particle. To do this, what we have to do is to use, let me open this, make a copy of that, the vector of the velocity, because the velocity is a vector, so it's the direction. So it's as easy as just connecting here. So now it's checking the velocity, the direction of each particle, of every particle. So you don't have to worry about the ray direction. And if we press play, you can see that it's working perfectly. And also, if you want to be pro, so now we define the ray length, something like 0.1, something like this. But sometimes, maybe it don't work, it works, maybe you have to increase this, maybe not. But if you want to be really pro, what you can define is use the vector, so the vector, the velocity of each particle, and calculate the length, right? The length. So to do this, it's really easy. We have to bring a vector math and select length. And this convert the vector in a float. And we can connect this here. So we don't have to worry about the ray length. That means that every ray length will be relative to the vector velocity. So when it's really close, for example, this one, when it will be really close, let me go a little before. When it's really close, it will be delayed. So with these two examples, with Raycast and geometry proximity, you can delay the particles when they hit an object. I'm just showing you both because in the future we are going to use Raycast because as you can see, we have more information about the object. In this tutorial, I'm not going to show how to make that they bounce or they do other things. I will do it in another tutorial, but at least now you know two ways of doing it. If you want to do it faster, use proximity. If you want to do it more professional, use Raycast. So if you like this video, please give a like, subscribe, and remember you can do this project and many more on my Patreon. And see you in the next tutorial.